Okay, so we're now here kind of towards the middle of the page to start this, to keep going on this next example. So we're in 2.1, page 2. We'll call this 2b. We'll see how long it takes us, but I may break this into a third video here, so we'll see how we go. Once again, now you can't see the whole list anymore on the screen, but you should have it in front of you on your notes. It's like overkill right now. We're practicing all the steps so that later in chapter 2, when these equations get more involved and more complicated, they look more complicated, they won't be hard to do because we'll be ready with our steps. So the very first step is to simplify. Of course, we should always keep the goal in mind. And the goal is that we want to get, in this case, z by itself. I always tend, when I'm handwriting, I always tend to put that little bar across the z so that I don't get it confused with a 2. My handwriting can get a little sloppy when I get excited, so I want to beware of not changing the math on me and then wondering what I did wrong. So the very first thing we need to check for is, do we need to do any simplifying, which means you're looking for any parentheses on either side of the equal sign. And in this case, there's no parentheses, so already done for us. We don't have to worry about that right now. Next thing we look for is, are there any like terms? And again, in this case, I go to the left side of the equal sign. There's no like terms, z plus 13. I go to the right side of the equal sign, no like terms. So that's taken care of. I'm just training myself for when there are going to be a situation where I have to do some simplifying first. Because the steps 1 and 2 up here remind us that we're first have to get it to that ax plus b equals c form. We need to rearrange it in our solvable form. And then we pick a side. We need z on one side or the other of the equal sign. And once again, it's just like going through the drive-thru. The dinner is just ready to be devoured. Z is only on one side of the equal sign. So that one's done for us. So now we're ready to start the process of solving. So we ask ourselves, what's happening to z? What's happening to the variable? And in terms of order of operations, if we put a number in for z, what we'd have to do next is we'd have to add 13 to it. That's what's happening to z. So if it wasn't an equation, it was just an expression, and I gave you a value for z, what would happen to it? Well, 13 would be added. So this is, just one of those one-step situations where only one thing is happening to the variable right now, and that is to add 13. Another way to write the what's happening list is to just write it in terms of what you see happening in order of operations. So you could say, well, you've got your z, and then you add 13. Okay. It's not always, don't jump to the conclusion that it's always copying the left side of the equation. As the problems get more difficult, you'll see how that changes a little bit. Okay. How this is really helpful. We're not just copying it. There's a method here. Trust me on this. Trust the process. We'll get there. Now we're going to undo this what's happening list. This is how you find out what are the steps to get z by itself. Okay. So if you take the time to make the what's happening list, solving is just as easy as following a list of directions. It will tell you exactly what to do. You don't have to wonder, do I add, do I subtract, do I multiply, do I divide, what do I do with this negative? The list will tell you what to do, or the picture here will tell you what to do. So if you're using your written verbal list, you reverse that order, you go up the list. If you're using the numbers method that I'm going to continue to develop as we go here, you would go, because you'll write the list headed in the direction left to right like you would read it, and then you'll go backwards through the list the other direction from right to left. And what does that mean? You're going to do the opposite of what you see. So as you go up the list, you change anything to its opposite operation. So add becomes subtract. The plus 13 becomes a minus 13. And if there were more than one thing happening, we would continue to switch around that list. And then we follow the directions. We go up the list. There's only one step, so this feels a little weird, a little overkill, but again, we're preparing ourselves for next time. And there's just one thing to do is we go from right to left. We're going to subtract 13. So we go ahead and do that. Now, the list tells us exactly what to do. Our job is to make sure We don't have to do any thinking now what we're supposed to do. Our only thing we now have to keep track of is what we do to one side, we do to the other. So it tells me to subtract 13. I'm going to do it to both sides of the equal sign. One on the left, one on the right. The purpose in this case of the one on the left is to get z by itself. We're undoing what's happening to z. So the z comes down, the equals comes down, but 13 minus 13 is 0. That's all that's left here. Okay, so it's like you have a 0 here. And then negative 15 minus 13 is going to be a negative 28. And again, I'm gonna work on the notes here, and I'm gonna work in class as if you've totally now you're able to own and understand and do positive negatives without issue. Okay, so that was our focus in many of the sections of Chapter 1. So if you still need help, please get that. All right, so before we drop our answer into a cute little set notation, that's what we're going to be practicing here in Math 60, so we're ready for 65 and beyond, is to check it. So we check it back in the original equation, z plus 13 equals negative 15. I give myself some workspace, and I'm going to check it. Give it a little question mark here. If I put negative 28 back into the original and I add 13 to it, will I get negative 15? And yes, I get negative 15 equals negative 15, so this is a true statement. That means my answer, I've checked it, it works. And now I'm free to give my final version, my grown-up, fancy, very, very elegant answer, and that is of negative 28. Okay, this is set notation. And we'll learn more about it as we go, but we're just starting to kind of up the level of our mathematics here. Okay, I'm going to see how long. All right, that's about a 7-minute video, so I'm going to pause that and we'll do the bottom examples in a third video. So we'll see you there.